Let's say we have two sets, A equaling 1, 2, 3, 4, 5, and B equaling 0, 2, 4, 6, and 8. With those members, the intersection of the sets A and B is written A intersect and upside down U, B. We want the elements that are in both A and B. So what's in both of these sets? There's a 2 in both, and there's a 4 in both. So I say that A intersect B equals the set 2, 4. A union B, the union of sets A and B is written A-U-D, U for union, and those elements can be in either A or B or in both. In other words, I just want to unite them all and take the whole thing. So if I take all of them, there's a 0, a 1, 2, 3, 4, 5, 6, and 8. That would be uniting the sets and taking all the members. The Venn diagram would have 2 and 4 in the middle of an overlapping set with 1, 3, and 5 only in A and 0, 6, and 8 only in B. This Venn diagram would be talking specifically about the intersection, not the union. The union would take all of them. In these two sets, W and V, W intersect V has no elements. So there's a term for that. We call it the empty set or the null set, meaning nothing in it. And it can be written a couple of different ways. We can write it like this, 0 with a line through it, or we can write it just brackets and don't put anything in the brackets. A Venn diagram of W intersect V as an empty set would be two circles that are disjoint. No elements in common. The union, again, would take all of the elements. -5, -4, -3, -2, -1, 1, 2, 3, 4, 5. So the union just wants to take everything. Let A equal the set of multiples of 2. Let B equal the set of multiples of 5. In your notes, use words to describe A intersect B. Pause the video while you write. Now pause the video and find 6 elements that A and B have in common in their intersection. Here are 6 elements that are in common to A and B. You may have listed a different 6 elements. Now in words describe this set. These would be the multiples of 10. A real-world example of needing to know this would be when you're trying to find a common denominator for 2 and 5. You would count by 2s and 5s till you find something in common, where 10 is the first number, and then 20 is the next, and 30 is the next. So every multiple of 10 will be a common multiple of 2 and 5, but 10 will be the least common multiple, so you would use it if you were adding or subtracting fractions. Pause the video and study example 2 on page 224. This question wants to know what possible temperatures you could use to put both the cookies and muffins in the oven at the same time. And so the overlap between them is anywhere from 325 to 350. So the final graph of this solution would be the degrees Fahrenheit could go anywhere from 325, so that would be a closed circle, to 350. That would be a closed circle, and then all the temperatures in between. So this would be our final answer of the intersection of baking cookies and muffins at the same time. So the solution to cookie temp intersect muffin temp is 325 is less than or equal to your degrees Fahrenheit, which is less than or equal to 350. This is your inequality, and this is your graphed number line. Pause the video to study the question and example on page 226. In this example, you have to be born, so you can't be 0, so that's an open circle. And you have to be 12 or younger, so closed circle on 12, and all the ages younger than that down to being born. And then 60 or older would be all the ones from 60, closed circle going up. So that's the final graph of this problem. And notice that none of these are in common with any of these, so if I was going to make a Venn diagram, it would be disjoint. You would have either these or these, but there's no overlapping. There's nothing that's in common to both groups.